Well, good evening. Welcome to Space Oddities. Happy New Year to everybody. Thank you for being with us on this Tuesday evening. Hope you all had a fantastically wonderful Christmas. You've all recovered from the festivities. And we're now in that, of course, depressing period after Christmas until the next paycheck arrives. So anyway, hope you're all okay, and hope everybody's not been too bad, what with the floods and the snow and everything else. And anyway, you're very welcome. For those of you who might be joining us for the first time, you are more than welcome. Enjoy yourself, and we hope you come and see us again. Just a reminder to everybody, please, if you haven't subscribed to the channel, which I'm sure most of you have, if there's anybody who hasn't subscribed to the channel, it'd be really helpful if you could just do that for us. And also, of course, if you could remember to like the video and leave a comment on the video after it's been published, that would really help us, because the YouTube algorithm looks at the number of likes and comments that we have when deciding whether to recommend our videos to other people. So we want them to do that, so the more likes and comments we have, the better. You can dislike us if you like, but I will kill you. So there we are. We are honoured and indeed quite tickled this evening to be joined by Sandra Grace. How are you, Sandra?
Hello, very well, thank you. Thanks for having me here.
Good. Good to see you.
Looking forward to it.
As you know, we do invite people who have been with us a while as viewers onto Space Oddities, and leave it up to them whether they want to come back afterwards. We did everything we could to dissuade Ian from doing that, but unfortunately he decided to stick around.
Thanks. That's a bugger, isn't it?
So there you are. We're looking forward to a great 2025 here on Space Oddities. We've got some great things coming up later in the year. We're looking forward to a great year in space, of course. This evening, we will be looking back over the year in space in 2024, and each of us will be picking a few things to show you that have stuck out in our minds as being the most memorable in 2024. If you have something that happened in space, whether it was astronomy or cosmology or astrophysics or space exploration, any event at all, or something you saw in the news that you particularly loved, put it in the chat. Let's hear about it. Tell us all about it, and we can discuss it. So that's what we've got on the agenda for this evening. Just a reminder about what's coming up, because we've got a fairly busy week here on Space Oddities. On Friday morning, the maiden launch of Blue Origin's New Glenn rocket takes place, and we will be covering that live. It's a bit of an early morning for us, not so early for me, of course, but for the other lads here. It's a bit of an early morning. Have a look on the channel for the details. We, as always, point out with live space launches that they are subject to change, but do keep an eye on the channel. Can anybody remember what time we're currently set for Friday morning with New Glenn?
Was it 6 a.m.
6 a.m. UK time.
UK time,
so
yeah.
Quarter to 6 UK time. Wants to get up at that
Gerard.
time. But you can, if you wish to. We'd love to see you. You're more than welcome, of course. Later the same day, the 7th test flight of SpaceX's Starship is taking place, but that's now been put back a day, and that's now happening at 6 a.m. UK time on Saturday morning. And again, we hope you can join us for the live coverage. That one should be particularly spectacular because it's a nighttime launch of Starship. We've never seen one before. And the most powerful rocket in the world taking off at night should really be a sight to behold. So we'll be going live with that at 6 UK on Saturday morning. We'll start broadcasting at about 1:45. So we hope you can join us for that, because it should be an absolutely spectacular launch. And of course, what with the maiden launch of New Glenn on Friday, will it work? That remains to be seen. So it'll be a bit of an exciting time. Just another reminder that on Tuesday, the 4th of February at 2 o'clock in the afternoon UK time, we're running a special educational event in conjunction with Polaris Dawn, the space mission captained by Gerard Isaacman that flew in September, and 2 of the astronauts, Sarah Gillis and Anna Maynon, will be joining us live for a Q&A session with 3 schools in Yorkshire, where they'll be answering questions from the children. So we're really looking forward to that. That should be a great event. So there you are. That's just coming up. Full details on the channel, of course. And also don't forget the Space Oddities website, which is Space Oddities, https:// space oddities. You'll also see all the events listed on the front page of the website as well. So that's where you can also keep up to date with us. Okay, well, there we are. So, as always, in time-honored tradition, before we get on to a review of 2024 in space, we're going to do the usual thing, the predictable thing, and go over to Roger for the look at the night sky and this week's viewers gallery. And as always, thank you for sending in your images to the gallery. If you would like to do that, please attach them to an email, one image per email, please, and address it to gallery@spaceoddities.space. And if you can include the image as an attachment rather than just pasting it into the email, it makes life a lot easier for us. We're always very grateful for your images. Any images that you do submit will be also contained within the viewers gallery on the Space Oddities website, and everybody who submits an image has got their own little gallery there. So that's an extra incentive to do it. So thank you for those of you who've been sending in your images over the Christmas period. So without more ado, let's go over to Roger.
Okay.
And I don't see your presentation there, Roger.
Oh, well, it's up with me.
Oh, okay. Just give me 1 second. Oh, the missing presentation. Nope, don't see it at all.
Oh.
Okay, just let me check. Ah, got it. It's been separated from you, Roger.
Oh,
Lost from your presentation, but there we are.
all right. Here we go then. So here we go for the first time this year for the 7th to 13th of January 2025. So we're currently just gone past the first quarter, and we're going to be experiencing on the 13th a full moon. So beware of that. No doubt it'll be clear, but tonight's clear and maybe tomorrow. So the moon will be quite bright even at its phase now, but at least we got some clear skies. Okay, so we're currently experiencing on the screen here what the night sky is at midnight. So as you can see, we've already got Orion heading over towards the western skies, but
That's happened quickly. Blimey.
I know. But it's still quite dominant in the southern skies, and we've also got Jupiter up there, still in Taurus, quite nicely positioned. And as we will progress through the week, we will get the moon gradually coming across the sky. So in a few days' time, we've got the moon going through the Pleiades again. So that might be another little photo opportunity. So there we go. And Jupiter and the moon following night. And as we proceed, it will just brighten up the sky as we do. Anyway, right, now this will be a little bit before sunset, but it just gives you an idea of how close Venus and Saturn are now. They are getting quite close, so we're starting to see the end of Saturn for the year, but as we can see, as we get closer and closer to the end of the week, they are getting more intimate together with their positions. So beware of that for a few days from next week. Right, so we do have some gallery shots for this week. Thank you very much. And the first one we have is from Jerry DeLay, and this is the Jellyfish Nebula in Gemini. His usual setup, and this is what he's produced. Absolutely amazing. Wowee.
Oh, wow.
Yeah,
That's
that's
pretty
amazing.
good, I think.
I don't
Very
think we've
nice.
seen the jellyfish before, have we?
That's
No.
it.
Yeah, I think we have.
Yes,
Yeah.
we have.
Okay,
I think-
perhaps
think
a
I-
second.
I think I put it in, but it was a narrowband image.
But that's an amazing image. Doesn't it really look like a jellyfish?
Yeah. You sort of see something which is uplighting the jellyfish, which is out of the field of view there as well.
Yeah.
Okay, so he's also done the California Nebula, and that's using his L Extreme filter, and I think you might be impressed. Look at that.
Oh wow.
Oh, wow.
Yeah,
That's a
that's
beautiful image, but I don't think it looks like California.
no, it doesn't really.
Is that before or after the big quake?
That's it.
It's Baja, California as well, though, don't we?
Hmm.
Wow, that's amazing.
Anyway, fantastic that
Wow,
one.
that is beautiful.
And then we've got one from Ian of Venus and the Moon conjunction, which we had last week. There
There
we
they
go.
are.
Yeah.
Great.
Just about.
Yeah.
Just about. That's good. Well done.
I didn't know the moon
And
was
we've-
bigger than Venus, though. It's a little odd.
Well, most
Going
of
on.
right. So you've got the Moon and Saturn from Ian as well here. But
I think the dot there might be Saturn. I'm not sure. I
the
don't
one
know.
that sort of like the 10:30 position.
Yeah.
There. About.
Yeah.
I think it is.
Yeah, you're probably right. Probably right.
Interesting.
Well
Nice
well
one.
executed.
Okay.
Well executed. Right, we've now got a moon taken with a sea star. Here we go, Lou. Watch this one. And it was set to a ×2 zoom. There we go.
Oh, look at
Oh,
that.
that's very nice. Very nice.
That's beautiful.
Yeah.
You would never
I
know
take
that
back
was done
everything
with
I
a sea
said
star.
about the sea star.
That's amazing
Right.
for the sea star, isn't it? Well done. That's brilliant.
Yeah, that's about one of the best of the moon I've seen with a sea star.
It's amazing, isn't it? That's truly amazing.
Right.
And you know, not so long ago, you would have had to pay a fortune
hang
for
on.
a telescope to get
Yeah,
it.
no.
Absolutely. Well, anyway. Okay, so there, it's my version of the Venus and the Moon, which was on the 3rd. There's two versions of it, one of a daytime and one of a almost nighttime version
Oh,
of it.
yeah.
Oh,
So you can see as it gradually got a little bit closer, I could crop it in a little bit more. So that was my with a William Optics Red Cat 51. Because that's about what I could fit in with the camera sensor that I had, so worked out quite well.
Nicely framed.
well done.
Yeah,
That's lovely.
didn't do too badly there. Right, so on the 2nd of January, the sun came out during the day, clear skies. So I thought I'd go and do some solar imaging. So we've got it in white light on the left and calcium on the right.
Beautiful.
Fantastic. Are these video images added together, or are these single shots?
These are compilations of a video, and there's a best percentage of what was captured.
Wow, that's lovely.
That's beautiful.
It's
Yeah.
amazing.
So it just gives you an idea of the different wavelengths that gives you so much difference in the imaging there, because you can sort of see all the sort of the faculae stuff on the. Yeah, it's a different layer. It's a different layer of an onion skin.
That's right.
Yeah. Of course, you could go a bit further and go to sodium, and then into the red end. So anyway, so this was last night of the moon, and I just managed to capture the V and the X, just about starting to come through there. I mean, the X is a bit more visible, but the V was just about poking out there. But they're right on the terminator, so that obviously helped to come out a lot better.
That's amazing.
So that was quite fun.
Mm-hmm.
And okay, so we've come to the end of the gallery.
Okay. All right. Well, thank you very much indeed, Roger. That's really nice. That's a lovely image of the moon, though, isn't it?
It is.
Let's
And
be
it's looking lovely out there again.
Yeah, absolutely.
Yeah.
Get rid of this.
The wire.
Okay, get rid of it.
Oh, it's going. Don't worry. Oh, I've lost it again. Okay. Oh, one sec. Give me a second. Just talk amongst yourselves.
Roger, I'd love to see, and maybe this is a challenge for our viewers, some images that demonstrate lunar libration, showing a little bit more.
Yeah, I mean, I've got enough images to be able to do that.
Yeah, very good. Okay, Gerard, thank you very much for your donation, mate. Much appreciated. Don't forget, if you would like to donate to Space Oddities, you can do so in one of a few different ways. Make it very easy. If you like to buy us a coffee, then you can scan this QR code on the screen and go to the buy us a coffee site, and you can buy us a coffee. We need to keep our caffeine levels up here on Space Oddities, of course, as always. And every bit of money donated goes towards keeping the channel running. So if you'd like to see us continue, you can support us like that. Also, you can click the super chat icon, which is the one with the $ in it, underneath the chat window that you see in front of you, and you can make a donation there as well. And as I said, everything is gratefully appreciated. I know it's not t-shirt weather, but don't forget we do have the Space Oddities merchandise. It's now more hoodies weather than t-shirt weather, of course. So we have, for your delectation and delight, the Space Oddities t-shirts and hoodies. The t-shirts start at £20, including £25, including UK postage and packing, which is a jolly good deal. And the hoodies start at £40, including UK postage and packing. Please add £10 to the total value of your order if you're ordering from abroad. So there we are. And again, all monies received go towards keeping the channel running and enabling us to do more and more things. Right.
And if you'd like to leave us your fortune in your will, call Andy. That will be.
Yeah, absolutely. And also, you know, if you've ever had that trouble to get to the cash point of forgetting your PIN number, we offer a service here. If you send us your card number and your PIN number, we'll keep it for you. So that's a free service, by the way. We don't charge anything for that. So you're more than welcome to do that. So there we are. You can trust us, honestly, God, you can trust us. Okay, we're going to move on with the main feature for tonight and look back at 2024, a bit of a retrospective, because there was such a lot happening in 2024. It was an amazing year for astronomy, for astrophysics, for cosmology, and the exploration of space, and particularly with the exploration of space, we had some spectacular things happening in 2024. So what we've done, each of us, is choose our two favorite things that happened in 2024 and talk about them a bit. So we're just going to go around everybody. And as I said at the beginning of the program, if you've got a favorite space event from 2024, put it in the chat and we can talk about it. And let's see how many of our favorites were your favorites as well. So we're going to start with Lou, actually. He's first on the list.
Let's start with Ed Stone.
Start with Ed Stone. Absolutely. So, Lou, would you like to tell us what this is all about?
Absolutely. There is no possible way that we could have any shout outs about the field of planetary science in 2024 without beginning with the passing of Dr. Ed Stone. We lost Ed on June 9th of that year. He was a giant in the field of planetary science, former director of NASA's Jet Propulsion Laboratory, and probably best known for his stint of 50 years as project scientist for the Voyager missions. A little bit about Ed in 1964. Oh, I got to change the, there we go. In 1964, Ed joined Caltech as a postdoctoral fellow. This is a picture of Jet Propulsion Lab, which is a federally funded research and development organization kind of tied to Caltech. And there he ran the university's Space Radiation Lab together with a guy named Ravi Vogt. And they worked closely on a number of NASA satellite missions, largely studying galactic cosmic rays and solar energetic particles, which Ed has a number of papers, peer-reviewed papers on. And in 1972, he was recommended to the JPL leadership for the position of Voyager project scientist. And again, he held that position for an amazing 50 years. Voyager's high profile with the public and the science community, lifted him up quite nicely. And in 1991, roughly 2 years after the mission completed its planetary flybys, which was 1989, the Neptune flyby, Ed became the director of JPL, and he served there until 2001. Under Ed's leadership, JPL was responsible for more than 24 missions and instruments. Highlights include the landing of Pathfinder on Mars, as the first Mars rover, Sojourner as well. In '96, the ESA US Cassini-Huygens mission, which was the first Saturn orbiter, and just a number of high-profile, largely, I think, planetary missions, including, of course, the flybys of Voyager and Voyager's extent into the outer solar system and beyond. There we go. So Ed served on 9 NASA missions as either the PI, the principal investigator, or the science instrument lead, and on 5 others as co-investigators, which is a key science instrument team member called a COI. And through these roles, primarily involved studying energetic ions from the sun and cosmic rays from the galaxy, as we mentioned. And he had the distinction of being one of the few scientists involved with both the mission that had come closest to the sun, Parker Solar Probe, and one that has traveled furthest from the sun, which is Voyager, of course. Ed won almost uncountable numbers of awards. I've presented a few here. Of note, there was an award named after him. This is the Ed Stone Award for Outstanding Research Publications. It's given annually by JPL, to recognize and encourage publication of significant research results in science and technology by JPL employees. And you can see a few of the other, well, no, actually you can't, but I can. Awards that he received: National Medal of Science in '91, Magellanic Premium 92, Carl Sagan Memorial Award in '99, Philip Klass Lifetime Achievement Award in 2007, Howard Hughes Memorial Award in 2014, and on and on and on. And if that wasn't enough, Minor Planet 5841 Stone was named after him. Here's a picture of Ed in the middle in the dark suit with some of the other Voyager primary investigators. He, of course, is best known for his work on Voyager. And I was a member of the Voyager team while Ed was running the show. And I was just so impressed with his ability to juggle the needs, the desires of 11 science instrument teams, all of whom felt that their data was the most important, and to balance that out with the right science, to get the most science back and the most meaningful science back. It was really nice. I mean, I didn't get to see it too much in real time, but the after effects of when these instrument sequences would be scheduled. It was just beautiful. So let's see. I think when we look back at Ed Stone's achievements, most people will look back at his role as Voyager project scientist. And the discoveries that Voyager made are almost without limit. It rewrote the textbooks. It rewrote every textbook on planetary science. We had not seen anything of Neptune or Uranus. We did not know that Jupiter had moons or that Io had volcanoes or that Triton had ice geysers. None of this. We hadn't resolved any of the outer solar system past Saturn. And so this is truly a game-changing mission for humanity, really. So he was also instrumental in communicating this information to the public. Again, 11 science teams, scientist project leads who are used to reporting their results in peer-reviewed journals. But he took the lead to make this a faster pace, or especially around encounter periods of Jupiter, Saturn, Uranus, and Neptune, kind of plus or minus 2 weeks, 3 weeks. He would, after the data came down each day in the early afternoon, the teams of scientists would decide what they thought were the best results for the day. And then they'd hold out their conclusions for feedback in front of the entire science steering group. And based on that discussion, Ed would choose the most interesting results to present to the media the next morning. There were morning media presentations every day during Encounter, and that included, of course, the public. The scientists would then hone their presentations that evening and even overnight. Some of us didn't sleep very long. And Stone would press us to come up with analogies that would make the material more approachable and interesting for the public, for lay audiences. So he really did a lot to popularize the mission and to make it more accessible to Americans and to the world. Here's just a picture of him at one of the daily press conferences. A few of the reporters are up there asking him questions. Here's a picture of Ed looking at some of the latest results from Voyager, some of the latest imaging results. This kind of picture was so common. Anytime a new result would come in, scientists would gather, and I believe in the light blue shirt there, just about is Carl Sagan. So I want to end this with 2 quotes. Dr. Nikki Fox, is head of the Science Mission Directorate at NASA headquarters, and Nikki said of Ed Stone's passing, "Ed Stone was a trailblazer who dared mighty things in space. He was a dear friend to all who knew him and a cherished mentor to Nikki personally. Ed took humanity on a planetary tour of our solar system and beyond, sending NASA where no spacecraft had gone before. His legacy has left a tremendous and profound impact on NASA, the scientific community, and the world. My condolences to his family and everyone who loved him. Thank you, Ed, for everything." And from Dr. Lori Leshin, who is the director of JPL at Caltech, and Caltech vice president, Laurie said, "Ed will be remembered as an energetic leader and scientist who expanded our knowledge of the universe from the sun to the planets to distant stars and sparked our collective imaginations about the mysteries and wonders of deep space. Ed's discoveries have fueled exploration of previously unseen corners of our solar system and will inspire future generations to reach new frontiers. He will be greatly missed and always remembered by the NASA, JPL, and Caltech communities and beyond." So that's Ed Stone.
Thank you very much. Yes, truly a great loss. I mean, we've said this before, that if there's one face I associate with the press coverage of Voyager back in the day, it is Ed Stone. He was synonymous with Voyager, and yeah, he was an amazing man, and a very humble man, I think, as well, from what the interviews that I've seen with him. Much missed. So rest in peace, Mr. Stone, and thank you for everything that you did to educate humanity and show them the wonders of our solar system, as well as other things that he did.
Yeah.
There we are. Okay, well, there we are. Oh, you've got something else for us, Lou, or do you want to do that later?
That's up to the MC of the program. I do have another presentation whenever you want.
Okay. All right. This is the one I can see here, presumably. Okay, let's do it now then. So let me just put this up for you. Hold on a second. Okay, tell us about this one then.
Okay, well, keeping with the theme of Voyager, kind of trying to stay in my swim lane here. I want to give a shout out to the Voyager 1 ground team. They performed an absolute miracle. I believe that's what it was called by Lori, by the Voyager project, the current Voyager project scientist. When Voyager 1, back in November of 23, started sending back garbage, unintelligible data from its science instruments. Nobody knew what was going on. It takes a day to send a signal to the spacecraft, roughly a day, a little over 22 hours, I think. It takes a day for the spacecraft to respond. So any hope of fixing this with early 1970s technology, forget it. It was just thought to be, Voyager had done its thing. Voyager 1 had done everything we'd asked of it and more, let it die in peace. But no, the ground system staff got into gear and they fixed this thing. And I'll show you what they did. Just to remind everyone, here's the launch of Voyager 1 and 2 in July and August of 1977. So we are approaching the 50-year anniversary in 2 years of Voyager, and both spacecraft are still operating and sending back useful data, fields and particles data, of now the interstellar medium. The two spacecraft traveled due to a fortuitous planetary alignment to Jupiter and Saturn for both spacecraft. Then Voyager 1, in order to get up close to Titan, got very high resolution images and other data of Titan and went on its way out of the solar system. Voyager 2 then went on to Uranus in 1986 and Neptune in 1989. And that was at the end of the what we call the planetary mission. At that point, the mission was handed over to the heliophysics branch of NASA as it began its journey into interstellar space. This is just an image of all of the instruments on board, and in order to preserve power, right, because it's got an RTG, radioisotopic thermoelectric generator, plutonium-238 power source. It has a finite lifetime. So in order to keep these things going as long as possible, many of the instruments that weren't really of any use anymore were cycled off. And the fields and particles instruments are being cycled even now, but we are receiving data from all of them. So let's see, let's go here. Okay, so what happened? Garbage data was being sent back, and initially the results were unclear. On board the Voyager spacecraft are three computer systems. The CCS, the Computer Command System, this is kind of the central CPU for the spacecraft. The AACS, Attitude, Articulation, and Control System, this controls the spacecraft's orientation. And the FDS, the Flight Data System, and this collects information from all of the science instruments and packages it before the telemetry system can send it back to Earth. And after pulling out some old dusty Fortran manuals and assembly language manuals that hadn't been looked at in years, it was figured out that there was something wrong with the flight data system. And that one of the chips in the flight data system, remember, this is old 1970s technology. I think this entire system here, this entire FDS had, I think it's maybe 8K of memory. Right? And that sounds funny by our standards, but that's what they said. So they had to go through some very old paper manuals to try to figure out what was wrong. And the conclusion was that it's, well, either old age, okay, perhaps, or perhaps a cosmic ray hit, what you might call a single event upset that had corrupted part of the memory. So again, this happened in November of 23. And this garbled data was traced back to the corrupted memory in the FDS. There were two possibilities, old age and cosmic ray hit. So getting it back online was viewed as an almost impossible task by the project scientist, I believe. But on April 18th of 2024, ground system engineers sent a command to relocate the affected code to another part of the spacecraft's memory. And the command reached Voyager 1 about a day later, and the spacecraft began returning data a day later. So it is now conducting normal science. A few tweaks remain. Let's see. Here we go.
It hasn't changed, Lou.
Yep. That's okay. We'll leave it here.
Okay.
A couple of they got good data back from 2 of the 4 instruments originally. The 2 other instruments required a little bit of additional work because they were dependent on the location of where the programming code was in the chips. But they are all 4 fields and particle instruments returning accurate data, which is just kind of a miracle, I would say. And here's a picture of the JPL group. You see in the closest to you, there's a man in a white shirt, a woman in a light blue shirt, moving left to right, and then a woman in a dark blue shirt. The dark blue, that's Linda Spilker, who was our liaison to JPL for our infrared science team way back when I was working on the project, and she is now the Voyager project scientist, taking over for Ed Stone. And here they are 2 days after they sent a command to move the code to other parts of the memory on the FDS, getting the return data that the spacecraft was now returning data again, and they were ecstatic. So wow. Really a remarkable task. And I think there's every reason to hope that both spacecraft will stay with us, returning good data through their anniversary of July and August 1977. So stay tuned. There are going to be big to-dos, big celebrations for what is now the longest living NASA mission, Voyagers 1 and 2.
Thank you very much. And you can guarantee that in 2027, we will be covering all of that on Space Oddities, of course. So thank you very much indeed, Lou. And what a remarkable achievement it was to get that spacecraft working at such a distance, a spacecraft of such venerable age. Absolutely unbelievable.
It's sending back data with the power of something like the light bulb in your refrigerator over 15 billion miles.
Oh, wow.
So if you want to
That's amazing.
It's fantastic, isn't it?
Wonder
It's
about
amazing. And I think I read that if to collect all of that data for 250,000 years, all that power for 250,000 years, it would light a Christmas tree bulb for 100th of a second. Something crazy like that.
Yeah.
It's mad. And to me, the amazing thing is that the Deep Space Network can still manage to separate that data from all the background noise in the solar system. I mean, it's just...
They had to make a number of improvements to the DSN in order to do this. That's certainly true.
Absolutely unbelievable. Fantastic, very, very clever people. And, well, I'm sure you're very proud of yourself, Lou, from being associated with that project. Because
I would say it was an honor to be associated with it. I'm proud of the ground crews and the all the other amazing people who worked on this and developed the program. It was It is. I don't kill it before it's gone. It is an amazing mission.
Yes, absolutely. And I think when the history books are written, it will go down as one of humanity's finest achievements, without a shadow of a doubt. Second, perhaps only to the moon landings. So there we are. Yeah, well, we can discuss that sometime. Okay, viewers, if you've got any views about that, then as ever, put them in the chat. We'd love to hear what you think about all that. So there we are. We're going to move on now to Michael's picks from 2024, or should I say pick?
Yeah.
Michael's going to tell us about what has been fairly regularly in the news in 2024, the Boeing Starliner. So tell us all about this then, Michael.
Okay, so yes, Starliner has been in the news quite a lot over 2024. Unfortunately, for mainly all of the wrong reasons. I'll go into that now. Okay, a little bit of background. Starliner was born out of the Commercial Crew Program, which began in 2011 following the retirement of the Space Shuttle. NASA turned to commercial industry for the development of crewed vehicles to perform ISS crew rotation. Spacecraft are owned and operated by the commercial company that built the capsules, and crew transportation is provided to NASA as a commercial service. Each flight capable of ferrying up to 4 astronauts to the ISS. So that's a bit of the background there. I'll move on to the next one. Successful bids from the private sector were received from Boeing, Blue Origin, Sierra Nevada, now Sierra Space, to develop vehicle proposals for ISS crew transport vehicles. In 2014, NASA awarded separate fixed price contracts to Boeing and SpaceX to provide crew transport services to the ISS. Right, what's that now? Okay. And only one company has fared well in this system, SpaceX. SpaceX's Crew Dragon began ISS crew transport services in 2020 and have been flying successful missions, plus non-ISS missions as well, since that year. So SpaceX have been doing very well with this program. But Boeing Starliner is still awaiting operational status. Okay, so here's a little bit of the timeline. Contracting awarded in 2014. 2015, NASA awards Boeing up to $4.2 billion to launch crews to the ISS. 2016, NASA purchases more Starliner flights for an additional $287 million. But then in 2017, which was the original launch date for the crewed flight test, but it was delayed multiple times due to several issues, mainly spacecraft mass issues, supply chain, and collaboration between NASA and the private sector. So quite a few different problems there. It wasn't until 2019, November, that a pad abort test was successfully completed. So that seemed to go okay. But also in 2019, in December, the flight test 1 failed due to a mission elapsed time clock issue, which failed just 31 minutes into the flight. The MET failure caused the spacecraft to make a wrong engine burn, so it couldn't get into the correct orbit to rendezvous and dock with the ISS. And the capsule was brought down prematurely into the White Sands desert not long after the flight took off. So that was the first major problem with the sending the spacecraft into orbit.
Can I just interject there at this point and say the reason why the clock failed was because when a mission lifts off is normally when the spacecraft clock is set to 0.
Yeah.
And for some reason, the spacecraft decided 90 minutes before launch that was when it was going to start its clock because of dodgy software.
Yeah.
The spacecraft thought it was an hour and a half further on in the mission than it actually was.
Yeah.
Which was crazy. But again, put down to very, very sloppy software testing because Boeing had never tested all of the individual software units that have to talk to each other during the flight. They'd never tested them together.
Right.
And it was crazy. It was just such bad project management. It was unbelievable. I just thought.
Okay, thank you. But then in 2022, another orbital flight test took place when Starliner actually did dock with the ISS, but not without troubles, I understand. And here's a photograph of that particular flight, which includes the SpaceX Dragon capsule as well. Up to the ISS. I think that's the only time. So
I've never actually seen that image before. That's right.
No, I didn't. I only looked at it recently. So it is nice to see the two commercial vehicles docked near each other like that. But so that happened in 22. But in 2024, came the crewed mission for the crewed flight test with carrying Butch Wilmore and Sonny Williams. After several delays, that flight actually took off on the 5th of June. But then on the 12th of June, because of problems in getting to the ISS on that particular flight, mainly with helium leaks and so forth, NASA delayed the return of Starliner. Initially, the flight was only due to last 8 to 10 days. But because of problems on the way to the ISS, NASA kept delaying the return of the astronauts. So on the 12th of June, they delayed the return. They delayed the return on the 18th of June again, and then on the 25th of June. And then NASA decided that Starliner wasn't safe enough to bring back the two astronauts, Butch Wilmore and Sonny Williams. So they decided to bring back the Starliner on his own without crew. And that happened on the 7th of September. And that was okay. But then the problem came that you got two astronauts on ISS without a ride home. NASA decided that the next SpaceX crew flight, Crew 9, originally carrying these 4 astronauts on the left, including 2 astronauts making their first flight, Zena Cartman and Stephanie Williams, they would have made their first flight on this mission. They decided to take the 2 astronauts out and just fly the mission with 2 astronauts, Nick Hay from NASA and Alexander Gorbanov from Russia, to enable 2 seats to become free for the return of Butch and Sonny in February originally. So that's what's happened there. So this was the initial crew manifest for the that particular Crew 9 flight. You can see Zena Cartman, Nick Hague, Stephanie Wilson, and Alexander Gorbanov. Then on the revised crew, launch was Nick Hague and Alexander Gorbanov. But the return crew includes Butch Wilmore and Sonny Williams. And as a result, the mission patch for Crew 9, rather than leaving 2 astronauts' names on the patch, the crew decided to not name anyone on the crew and just have the Crew 9 logo without the astronauts' names, which which has only happened, I believe, a couple of times before.
Right, right.
Okay, so on the 28th of September, the Crew 9 launched with 2 crew. And at the moment, the Crew 9 will return with Butch and Sonny in March 2025, and a much longer, several months longer mission than they intended to be on than when they started. So that's a quick rundown of what's happened with Starliner. We still don't know when Starliner will fly, if at all, with crew again. Let's wait to hear about that. Okay.
Well, because Boeing may well be trying to get out of space altogether as far as the Starliner goes.
Right.
And sell, either just cancel it altogether or sell it to another company.
Right.
Because the new CEO of Boeing is very keen, obviously, to cut costs, and because it's cost with all the problems they've had with the dodgy thrusters and the computer problems, everything else that's gone so wrong for this program. It's cost them over $2 billion so far that they've had to fork out for their own errors, and it's like pouring money down a drain, basically.
Yeah.
So I think, Michael, I think you'd agree with me. This year we're probably going to get a definitive decision about the future of Starliner.
Yeah, we need to. Yeah.
So it could be an interesting year for Boeing. So
because the other thing with Starliner it was proposed to be not just a ferry for the ISS, but proposed new space stations that are coming online in the next few years. So
absolutely, but particularly with things like orbital reef.
Yeah.
And as you said, proposed space stations.
Yeah.
It was meant to be the main vehicle that Blue Origin were going to use as their crew transfer, and it's all gone horribly wrong. So we'll see. Well, thank you very much for that, Michael.
Yeah.
As I understand it, they'll be up as many months as days they were supposed to be up.
Yeah, that's about right.
Yeah. So,
so there we are. Okay. Right. Well, thank you very much for that, for reminding us of what a disastrous year it was for Boeing Starliner in 2024, much like any other fact that it's been particularly bad this year. Stranding astronauts on a space station for a number of days equal to the number of months equal to the number of days that they should have spent there is not good, obviously. There've been widespread concern about Sunita Williams. She doesn't look well on the ISS, and she appears to have lost a lot of weight and looks very gaunt. And although NASA are saying, obviously she's fine, but there's much speculation about her health. So
I'm sure they'll both be put in some kind of isolation when they're back.
Definitely, yeah, sure. So they will. Apparently, she has a problem with protein. Her body doesn't appear to be absorbing protein from the food as much as it should be.
Yeah.
So they're a bit worried. They don't know whether that's to do with her flight or whether it's a previously unknown medical.
Yeah.
But it's a problem, and obviously we wish her all the best and come home soon, Sunita. And that's it. All right. Well, we're now going to go over to Roger. Let's just find Rogers. Can I see your? Oh yes, here it is. I found it. There we are. So what Roger has picked for us is the last flight of Ingenuity.
Yeah.
Very sad.
Yes, it was.
Oh, I was going to mention that one.
Oh. Yeah, it's just Well, it shouldn't have been its last flight because it was only vaguely programmed to have about 5 test flights to start with, but it managed to do 72. And that was only because the rotor blades got damaged on its flight. Probably due to the fact that it hit the ground, not realizing how high up it was above, to damage 2 of the rotor blades and disable its flight procedure. So that's been rather unfortunate. But there we go. So we've managed to get such a magnificent view of the surrounding areas from this little helicopter. The first flight on another planet, so it's even more successful than the Wright brothers was. So there we go. I mean, it initially landed because of how it got there. It was initially arriving on the 18th of February. But its first launch was on the 19th of April. So it was a little while after, but not too far. So its first flight was from Wright Brothers Field, which is quite appropriate, really, to name it there, because of the Wright Brothers' first flight on the Earth, they used the same name for its first flight from the surface of the Mars. So,
I wonder what Wilbur and Orville would have made of that. They wouldn't have believed it, would they?
No, because it's only 1% of the atmosphere that the propellers had to try and lift itself off.
Yeah.
And it's been quite amazing. I mean, it's only about 4 pounds in weight as it was. So obviously the minimal amount of weight will obviously help with those large rotor blades to give enough pull to get it off the ground. So it's been quite amazing. So the first flight was on the 19th of April, and the last flight was the 18th of January. So 72 flights in total, and it's been absolutely awesome. Nobody could have ever imagined how successful that this little helicopter has actually managed to achieve. I mean, here's some other statistics. Its maximum speed was 22.4 miles an hour, 36 kilometers an hour, and it's managed to get up to 79 feet above the surface, and it's traveled just over 10 miles in all its flights all around the area. So
Wow.
all well and good to that. So we've done really, really well on there. So here's some basic figures that we've actually got. We've we've got 6 charged Sony lithium-ion batteries, which are obviously solar powered, and it's only got 350 watts of power to supply the camera and the propeller equipment to fly itself around. So it's done quite well. And in all that time, it's only flown 2 hours and 8 minutes for 72 flights. So obviously the very first flights were very, very brief, basically straight up hover and back down again. But nevertheless, it's been very successful.
Indeed.
But this, unfortunately, as you can see from here, the damage on the rotor blade, which was severe enough, on 2 of the blades, to disable the flight capabilities of the poor little helicopter, that it was just beyond capabilities. But apparently it's still actually recording the some data down there. So if they can manage to retrieve the hard drive from Ingenuity, they might find some interesting daily data of the temperatures on the surface and any other information that it actually did record in the meanwhile. But obviously it depends on how well the power supply to that unit is actually working. If I can just give you a brief overview of some of the videos that we have actually managed to see, especially the my favourite bit is the actual landing of it coming down onto the surface. So let me just try and share the screen. And window. Right, okay. So, can you see that? Or hopefully.
No.
We still see the shadow of the propeller.
Mm.
Oh, why can I not share that? No.
Just while you're having a look at that, they think the reason why it had such a hard landing was because its navigation system relies on landmarks, if you like, things of note on the ground below it, and it was traveling over a particularly featureless sand dune at the time, and it just lost its bearings and it didn't know how high it was or where it was, and that's the reason that it came a cropper when it landed, unfortunately.
Right. Okay. Can you see the shared screen?
We can still see the same slide, unfortunately.
Oh. Why does it not show you the videos?
Don't know.
But, oh well, that was a nice idea.
Well, while you're wrestling with that, as a result of the success of Ingenuity, NASA have actually designed, if you like, the next generation of aerial vehicle for Mars, which at the moment is going by the name of the Mars Chopper, and it looks like this. Oh, it did look like that. Where's that gone? Okay, that's strange.
Nothing's happening.
Oh, not to worry. Let's just try that again. They've designed this super vehicle known as at the moment, the Mars Chopper. I'm not quite sure. There we are.
Wow.
Yeah,
My goodness.
I'll put your fingers out, do you?
yeah. It's obviously got a lot more lift. It's a lot more capable. It's about the size of a car, and this is the design that's been put forward to carry on with the legacy of Ingenuity. So there we are. That's a bit unfortunate. Okay. Yeah, sorry, couldn't show the videos. I don't know what happened there, but anyway.
Okay. Darn it.
Oh, I know. Technology, eh? Isn't it great when it works? So there we are. Okay, well, let's move on. Perhaps wrestle with that and come back to that a bit later then.
Okay.
And we're now going to go over to Ian. So, Ian, what's your pick from 2024?
Well, I've got a Simpson, Lisa Simpson, indeed, and
Really?
so I'm looking forward. In fact, I'm looking into the future from things that were postulated in this year. Well, you haven't got it, Andy, so I'll go from beginning. Where's it gone? It's hidden. No. No. Yeah. No. Wrong one. Right one. From beginning. There you go. Alt tab. Back to you guys. And share. Share. Oops. Hang on.
Got it?
There you go. That's me. Can you see that? Laser interferometer
1 second.
space.
Display that. There we are.
Yeah. Good. So, I can't see you now, but that doesn't really matter. So, what is this? It's about this fella. Where is he going? Is that going? Hi. Where's that? This fella here. Gravitational waves, which were first theorized by Einstein way back when. And we have ground-based telescopes which have tried to find these things, but as it turns out, they're created basically by the collision of supermassive black holes or the neutron stars, that kind of thing. But as it turns out, many of the astronomical phenomena which we wish to study are either extremely dim or invisible in any form of light. So gravity seems to produce waves too. And LIGO, I'll come back to what the problem was, because I'm pushing ahead a bit. In 2015, LIGO made history by detecting the first waves, and then LIGO and Virgo in Europe have been trying to find more. Neutron stars and black holes merging seem to create these waves. Now, the problem is, many of these are much bigger than the Earth itself. So these waves absolutely are way too big. So what we need is something out there in space. So the solution is an array of spacecraft will create an equilateral triangle in space, separated by millions of miles, and will be able to detect 0.1 megahertz, or millihertz rather, LIGO's 10 hertz at the smallest. LISA will avoid the noise and regions of the spectrum inaccessible from Earth. There will be ESA-led mission scheduled for the mid-2030s, but it's in production right now. And if
So,
this
sorry,
will work,
does that mean
yeah, here we go. The gravitation.
Sorry,
Yeah.
I was going to say, does that mean you say it's in production right now? So does that mean it might actually launch earlier than the 2030s?
We may do. It's being postulated at the moment. So I think when I say it's in production, sorry, I mean it's being looked at, and all the theory is being slightly confusing there.
Because I think this year,
I
think this year was the year that it got the official go-ahead, didn't it, from ESA?
Yes, that's right.
Yeah.
That's it. So the theory is all there, but the building and so on is still to happen yet, basically. So this is the bit here. If you can see can you see my?
Yeah, you can see that.
My cursor. Yeah, you can see my cursor. This bit is what we're trying to look at. It's all these images are NASA for the most part, by the way. I better just say that, just in case I get in trouble. So we've got the supermassive black holes of kind of what we want to look at with LISA, which is this bit here, right down here. The bigger things are, well, they can be done by the other things. So the terrestrial interferometers, rotating neutron stars and supernovae and so on, and other things. We've got the quantum fluctuations in the early universe, which can be done again by other means, but it's this little narrow band that we're trying to find. So what does LISA look like? Hopefully this will work, because this is, come on, move. Right. Yeah, here we go. You seen that?
Yeah.
You've seen the big triangle going behind this. So it's a massive, huge thing. Look at the size of the Earth compared to it. It is absolutely enormous. It will be able to get enormous waves at the moment because, as I say, the ground-based telescopes are just too close together, or they just can't do it. And the launch of the 3 spacecraft on an Ariane 6 rocket led by ESA. LISA is made possible by a collaboration between ESA, its member state organizations, NASA, and an international consortium of scientists, the LISA Consortium. So that was for ESA in January 24. That's when they said it. It's still in consultation, will be for some time. Watch this space in 10 years' time, folks. So that's my first presentation.
Thank you very much. That's great. LISA has all the makings of a fantastic mission, which will open up our understanding of the gravitational wave universe immensely. And we should just say again that it was preceded by a mission called LISA Pathfinder, which tested the technology out in orbit. And it actually far exceeded anybody's expectations. So this was one of the things that enabled the mission to go ahead, because it performed so well. And as you say, using lasers over millions of kilometers to detect gravitational waves is going to be absolutely amazing. My only worry is that I hope I'm still here in 10 years to see it come
Well,
through.
there is that. I know. It's a bit annoying into 10 years, but you know.
It's a bit worrying. When you get to the older age, you start getting space missions planned for 20, 30 years in the future. You think, oh my God, you know. Because I don't know about you, I measure my own mortality by the space missions that are coming up. This one. Oh, it's so depressing. Anyway, what else have you got for us here? You've got something else for us?
I have, if I can get you back, no, rather than this, I have Musk for you. So that's the problem, isn't it? Hang on.
Oh.
Where's he gone?
Right.
Yeah. So I'm going to... Oh, I can't do this. Why can't I get you back up? No, can't get you back up now. Ah, there you are. So sharing the screen and window, and it's that one. Share, except it isn't. Mine's not bonkers. No, wait, that's not it. When you want to wake up in the morning and think the future is going to be great, and that's what being a spacefaring civilization is all about.
Right, that
future and thinking that the
Ian, just one thing. We still can't see your presentation.
Oh, right. Okay. Oh, hang on.
Do you want? Should I come back to you, Ian? Or are you okay?
Yeah.
Okay, we'll come back then. Okay, well, I guess that just leaves.
Back to whoever.
Okay, we'll come back to you. Okay, I'd like you to cast your minds back to the film Aliens. And there's a scene in Aliens where Ripley finds the child Newt for the first time. And Newt says to Ripley something to the effect of, when you're young, you're scared of monsters and your parents tell you that they don't exist, but they do, don't they? And of course, Ripley has to tell her, yes, they do. And monsters do exist. And I want to talk to you about a discovery of one monster in 2024. And its name is this. It is J0529 4351. And this is an absolute monster. And it's almost incomprehensible how much of a monster this is. So what is this? This is a quasar. A quasar is the black hole engine at the center of a young galaxy that pumps out incredible quantities of radiation, but it also consumes a lot of material. So we see them in young galaxies when the young galaxies were still full of a lot of gas and dust, and the black hole, the supermassive black hole at the center, consumes the material that's surrounding it. So why is this particular one a monster? Well, firstly, it consumes an unbelievable amount of the material that's surrounding it. Now, most supermassive black holes, most quasars that we know, they tend to consume around 0.1 to 1 solar masses of material every year. This quasar is consuming 1 solar mass of material every day. So if you can imagine the mass of the sun being consumed by this black hole every day, this is the hungriest quasar ever seen. But it doesn't stop there. So it's incredibly bright. And in fact, this now holds the record for the brightest object in the universe. Would anybody like to guess how much brighter than the sun this is? Any wild guesses?
10 billion. 10 billion.
10 billion.
100 billion.
Right, 100 billion. You're way off. Let's deal with the distance first of all. This is 12 billion light years away. and it is over 500 trillion times brighter than the sun.
Wow.
Yeah, can you imagine an object that is 500 trillion times brighter than the sun? And in case anybody's interested, it's outputting 10 to the 48 ergs per second of energy, which is an unbelievable amount of energy. And it is a massive supermassive black hole. It has 17 times 17 billion times the mass of our sun. This is a true monster, but it doesn't stop there. And what first alerted astronomers to it, apart from its brightness, was its size, because it has an accretion disk, the swirling disk of material around it, that is frankly difficult to comprehend, because the accretion disk is 7 light years across. It has an accretion disk measuring 7 light years in diameter, which is around 15,000 times the distance from the sun to Neptune. Now, nothing like this, even in the young universe, has ever been seen before. So this quasar is holding all sorts of records now. It's the hungriest quasar. It's the brightest object in the universe. It has the biggest accretion disk ever seen. Why is it like this? Nobody knows. But unbelievably, it's been known about for a long time. It actually appears in images from the European Southern Observatory Schmidt Southern Sky Survey going right back to 1980, but it wasn't recognized as a quasar until very recently. So this is a real monster. I've never ever heard of anything like this before. And of course, astronomers will be trying to figure out why this quasar is so extreme. So there we are. So that was one of my discoveries from this year, the recognition of this quasar and the measurements that made us realize how much of a monster this was. My second choice is the year of the starship, because 2024, and I think Sandra would have picked this one as well, wouldn't you, Sandra?
Yes, when I was. Yeah.
2024 has been the year of Starship. It's been an amazing year for SpaceX's Starship. There have been 4 test flights of Starship in this year. Flight 3 didn't go very well. The booster didn't make it through the mission, and it broke up and exploded. The ship broke up in re-entry, but it obviously provided valuable data. Flight 4 was the first one where both the booster and the ship achieved successful controlled landings in the ocean. Flight 5, which was headlines around the world, was the one where they managed to successfully catch the booster with the tower, that amazing scene. And then Flight 6, they were intending to catch the booster again, but there was a loss of communication. You see in the image on the left there, that aerial on top of the launch tower, that's the thing that communicates with the Starship. And it was damaged as the vehicle lifted off, and the tower lost contact with the booster. And although SpaceX said they think it would have worked even without that communication, they weren't going to try it. So the booster automatically decided it wasn't going to make it back to the tower because of the loss of communication, and automatically diverted itself for a splashdown in the Gulf of Mexico. So what we're waiting for on Saturday now is for a repeat of that catch of the booster, because it was spectacular, and it'll be happening during darkness as well. So that will be even more spectacular. So we hope you can join us early on Saturday morning for that flight. So by the end of 2024, there were 4 test flights, which would double the number from 2023. SpaceX is probably going to get approval from the FAA for 25 flights of the Starship this year, 25 in 25, and they want to accelerate rapidly from there. maybe going up to 100 flights in 2026 if they get approval. So it's going to be 2024 was an amazing year for the SpaceX Starship. 2025 promises to be even more outrageously wonderful. And just to finish this, we can't leave this without reliving that fantastic moment.
Landing burn has been ignited. We're now down to 3 Raptor engines. We can see those chopsticks now.
Macadilla had popped his shirt.
This is absolutely insane. On the first ever attempt, we have successfully caught the Super Heavy booster back at the launch tower.
What are you trying to do?
Are you kidding me?
So there we are. So I just had to relive that with you viewers, because I mean, I've seen people calling that one of humans' greatest engineering achievements ever, and I'm not going to disagree, because it was frankly. I've had loads of people who are not remotely interested in space flight or anything to do with space say to me, "Did you see them catching that rocket?" So it did a great deal of interest among the public, which is what it's all about, isn't it? Which is what we're trying to do here, of course. Just people interested in stuff.
Yeah. It's like science fiction, isn't it?
Yeah, absolutely. It caught people's imagination. So just to go on, what I've done, I'm going to take you through what's coming up in space in 2025. What have we got coming up this year? So we'll go through it in chronological order. So there's an opposition of Mars on January the 16th. Mars is going to be its closest approach to the Earth. And obviously that's going to be a great time for observing Mars. On January the 17th and 18th, there's a conjunction of Venus and Saturn. They're going to appear very close in the sky together. So more photo opportunities, guys. So get out there and take your photos and send them into the gallery, please. gallery@spaceoddities.space. On February the 14th, there's a launch of NASA's Sphere X mission to map the cosmos, and the Punch mission to study the sun's outer corona. March the 13th and 14th, we have a total lunar eclipse. This will be visible from parts of Europe, Africa, and Asia. Europe, we're going to be spoiled for eclipses this year. We've got 3 eclipses this year. And that's followed on March the 29th by a partial solar eclipse, visible from parts of North America, Europe, and Asia. I don't know whether you're going to get to see that one, Lou. Do you know?
Yep.
Yeah.
Should.
Yeah. So that's another eclipse. That's the second of 3 eclipses this year that you'll be able to see. In April, we've got the launch of IMAP, the Interstellar Mapping and Acceleration Probe, and the Solar Cruiser mission scheduled for launch to study the heliosphere and solar phenomena. Again, important missions to try and understand the sun a bit more, so we can protect ourselves more against bad solar events. We've got a mission in May. NASA's launching TSIS-2 to measure solar irradiance. That's the amount of radiation that reaches the Earth and its impact on Earth's climate. Interesting one in June, we've got the Haven 1 private space station launched by the company Vast. Now, what they're doing is launching the first commercial crewed space station, offering 30-day stays in orbit for astronauts and obviously very rich civilians. But this is a really big step forward in terms of orbiting habitats. So we'll be covering that obviously in June. Big step forward for people living in space for long periods. And then in September, we've got another eclipse. This is a total lunar eclipse. And this is visible again from parts of the Americas, Europe, and Africa. So we're a bit spoiled for eclipses this year. In November, Saturn's rings do a disappearing trick. As you're probably aware, every so many number of years, about once every 14 years, Saturn's rings appear edge-on from the Earth. They don't disappear together, but Saturn's rings will form just a very thin line across the planet seen from the Earth because of the angle in November. After that, the rings will start opening up again. And then in November, we've got very important launches for the Lunar Gateway, which is the space station which is going to orbit the moon to act as a staging post for astronauts exploring the moon. 2 units are being launched to the moon for that. The so-called HALO, the habitation and logistics output, and the power and propulsion element of the space station will be launched to the moon in November. So that's what we've got coming up for you in 2025. Obviously, keep tuned in to us, and we will cover as many of these as we possibly can and bring you news of all of them. But the fact that we've got 3 eclipses this year will provide some great photo opportunities. So get out there and take some photos. So let me just get back into the land of the living. And just on the back of that, just give me 1 second, because I've got something for you. Oh, my mouse pointer seems to disappear. Right, so what we're going to do here is, just give me 1 second, that calendar of space events coming up in 2025, I've actually created it as a PDF file, and if you would like to download that, free, of course, then if you look in the chat, there we are, there's a link, click on that link and you can download that PDF so you've got it handy to remind you what's coming up in space this year. That's your calendar. But also, in the same folder, there is also the NASA Space Science calendar for 2025, which is a beautifully produced calendar. And you can also download that from that folder as well. And if you want to print it out and have a lovely NASA Space Science calendar on your wall, it's really well done. It's really good. So there we are. So that's my bit over. That was my look back at 2024. Ian, how are you fixed now?
Yeah, maybe next week. A bit political at the moment, if you think.
Okay, all right. Well, we'll leave that till next week. Okay.
If that's okay.
Yeah. Sandra said your screen froze. Is it back now? Can you hear us, Sandra? I think we've lost Sandra. Let me just check. Hang on, what's going on with Sandra?
No, I've just got a black screen. For some reason.
Okay. Well, what you could do is to close that tab in your browser and come back in with the link that I gave you, and that should fix it. I think that's the only way we're going to cure that.
While you're doing that, I have just 2 thoughts.
Okay, I'll
presentations.
Sorry, Lou.
Just 2 thoughts from the presentations. One, I am very happy to see the launch of Lunar Gateway in November. I have heard nothing about its progress, so I've asked. So I hope it happens in November, but I have a little reluctant to hope for that date. The second is that you were mentioning LISA, right? Back in 2003, I was holding an International Science Data Center Symposium at Goddard, and Joan Centrella spoke about the LISA project.
Oh, right.
Back in 2003. Funding was canceled for the project for quite some time, and it's great to hear that it's being funded again. But it's over 20 years ago.
Gosh, yeah, absolutely. And as I said earlier, the success of the Pathfinder mission, I think made ESA realize they had to go through with it. It's all cutting edge technology, of course, and it worked first time better than anybody expected. So. The scientists put a lot of pressure on ESA to greenlight the mission, which they have. So this is fantastic news, and who knows what we're going to discover. But we'll keep you posted on all of that. Viewers, apologies. There's some sort of weird stuff in the background of the sound tonight. The cross sounds like cross, sort of like a cross line on a telephone, and I've tried to isolate it and get rid of it. I haven't managed to do so. I don't know where it's coming from, basically. But if you're hearing something really annoying in the background, circumstances beyond their control, I'm afraid. Apologies for that. Daz in the chat here says Chandra, the NASA, the venerable Chandra X-ray Observatory, has had a reprieve. I didn't know this. Do you know anything about this, Lou?
I don't, but let's see. I know that there's interest in having one large mission being able to view the universe in every wavelength, and so I don't know what's out there observing in X-ray. So if there isn't, then it's important to keep Chandra going for a while.
Absolutely. Absolutely it is. So there we are. Yeah, Derek says the sound is generally out of whack. So Keith, yeah, shocking sound. Don't know where it's coming from, to be honest. I don't know why we're having these problems with the sound this evening. So apologies, viewers. But you know what it's like, technology, and you can never guarantee it's going to work. So we will obviously try and fix it for next week if we can find out what's causing it. So there we are. Right then, well, I guess that brings us to the end of the evening. Obviously, Daz is not here to do his normal solar presentation, but I'm sure he'll be back next week, and we wish you all the best recovering from that nasty lurgy that you've got, Daz. And I'm sure he'll be back on his usual bouncing form next week to tell us about what's going on the sun, because obviously over Christmas and New Year there was some spectacular aurorae. And if you get any images of the aurora, send them in to us. So we'd love to have them in the gallery. So there we are. Like to give a big thank you to Sandra for being here this evening. Hope you've enjoyed yourself, Sandra. And you are more than welcome at any time to just drop back.
Yeah, I'm still here.
Yes, we can see you. We can see and hear you. Yes, we can see and hear you. So, can you hear us, Sandra?
Oh, right. Oh, yeah.
Okay.
I can't see myself.
Oh, we can see you.
Yeah, it's been great. Thanks. Thank you.
Good. Hope you've enjoyed yourself. And you've got the link. You are welcome to come back in at any time. Just drop in. You don't need to be invited. You're more than welcome anytime to drop in and join us if you would like to.
Yeah, I will do, definitely.
The link doesn't change. It's permanent. So
Thank you. Yes, I will do.
And if you get any problems with it, let me know. Okay.
If you could drop in kind of right on top of Roger's images, that would be great. Thank you.
Yeah, absolutely. Yeah. There we are. So it's been lovely to meet you, Sandra, and take care of yourself, and we will speak soon, I'm sure. But from all of us at Space Oddities, do join us again next week. I'm not quite sure what we've got on the agenda for next week, but we will obviously have something. Later in the month. Yeah, I was just about to say later in the month, the last Tuesday of the month, which I believe is the 28th, Ian will be giving us a quiz, and it's an astronomy and music quiz this time. So that sounds fun. So do join us on Tuesday the 28th for the astronomy and music quiz to display your knowledge of astronomy and music. So we're looking forward to that, and that just leaves us next week, really. So, and the week after. So we'll sort something out for you for next week. But we'd like to thank you all, obviously, very much for being with us. It's been great to have you along for the ride this evening. Hope you've enjoyed our little look back at 2024. But 2025 looks like an incredible year coming up in space, in all the space sciences and space exploration. So we're going to really enjoy bringing that to you in 2025. So from all of us at Space Oddities, take care of yourselves. Be good. If you can't be good, be average. And we will see you back here at 8 o'clock UK time. Don't forget the website, Space Oddities, https://spaceoddities.space. Don't forget the Facebook group, where we keep you up to date with what's going on as well. But do go and have a look at the website. And if you've got any feedback or comments or suggestions or death threats or anything like that about the website, then you can actually mail us at any time at info@spaceoddities.space. info@spaceoddities.space is our general email address. And we'd love to hear your feedback, thoughts, comments, suggestions, whatever. Or if you're just lonely and you want somebody to talk to, you just drop us a mail. And as I said, if you want to drop us your card number and your PIN as well to look after, we'll do that for you. So from all of us at Space Oddities, have a fantastic week, everybody. Stay warm in the inclement winter weather. We'll see you back here next week. So from all of us, bye-bye.
Happy New Year.
Happy New Year.